So Europe is really where there's all sorts of feed-in tariffs. That's really what drove the industry in Germany and Germany and in Denmark and in Spain. But since Ontario passed the law originally in February, and it's just come into force in the last few weeks. But since Ontario moved first, since then we've seen Vermont pass a feed-in tariff, Hawaii's passed a feed-in tariff, California has, and there's even a city in Gainesville, Florida, who's passed a solar feed-in tariff as a local municipal utility. The United Kingdom is looking at doing a feed-in tariff, and recently China and India have both announced a feed-in tariff, and I think that is big news. We're talking about half the planet now is taking this very, very seriously, and the dollars that China has invested in wind energy and solar energy, I think, are going to change the market in the next 2 or 3 years. This is a big deal. So who's next? Could Alberta be next? I heard a few snickers. I'll talk a little bit about a study that I did with a friend of mine, Jeff Bell. This was a study we did on the technical potential for renewable energy in Alberta. And so I'm going to quickly talk about, I wasn't going to go into it, but I thought I should just give you the highlights of what we looked at in terms of what's technically possible in Alberta. And I'm not going to go through the gory details of it, but it's on our webpage if you want to read more about it. So what we looked at what's currently the Alberta system is and what we could be, if we looked at what all these other jurisdictions are doing globally, what we could be doing in Alberta and what the potential is in Alberta. This is data that we synthesized from the Alberta Electric System Operator. And so what this is this is hourly data here. And you can see this is sort of a day in Alberta in terms of where our power is coming from. So you can see most of the power is met by coal. And then natural gas cogeneration sort of makes up the bulk of it, those two together. And then there's a little bit of wind and hydro and some imports from British Columbia or Saskatchewan. But what you can see here is you can kind of follow along a day in Alberta's electricity system where you've got sort of everyone sleeping here, and then they wake up and turn on the coffee pots in the morning and then go to work. And then see there's sort of a peak during the day, during working hours, and then everyone comes home and cooks their dinner. And you get a peak, and then everyone sort of turns their TVs on and goes to bed, and that's the end of a day and the system in Alberta. And so if you look carefully here, you can pick out sort of where the weekends are. There's usually 2 days in a row, so 1, 2, 3, 4, 5, and then 2 days in a row that are down, and sort of 5 days up. And then your Christmas time is obviously a little bit quieter. But anyway, there's a couple of interesting points here. You can see that the bulk of the demand in Alberta is being met by coal. A few interesting points is that Alberta's demand, or coal, a couple of things. Coal actually is not a pure baseload. It is able to cycle up and down. It's not something that has to be on 24/7. You can see there's fairly large ups and downs that can follow the load up and down. Another interesting thing here is these are all the wind. This is actual data. These are the wind power plants in Alberta. And you can see that people often say wind is intermittent and you can't count on it. But I think what's important to learn from this here is that there's no sudden stops and sudden starts. You don't see sort of wind start and then wind stop and wind start and wind stop. It does come and it go, but it is a gradual change. And you can see that the changes in wind output are similar to what the grid system is already capable of handling. And so I think that's an important lesson to learn about when people talk about intermittency of renewables, is that the grid is already able to handle ups and downs in the demand on its own. And so, and you can see that when wind comes online, it can be online for several days at a time, and then it can come off. And again, the grid is able to handle that. So a few important and interesting lessons to learn there. So again, coming back to the straight line, here it is. There's the Alberta straight line. This is currently where we're at in Alberta. And what we were looking at, there's a bunch of different forecasts that were done for Alberta and where Alberta is going to be 20 years from now. And so keeping in mind, of course, that Alberta is currently the dirtiest system in Canada. So here we are this was done in 2007. So this is, again, this is the largest source of electricity emissions in Canada. And we're talking about looking at a forecast of doubling that over the next 20 years. Again, this was done 2 years ago when we were in the midst of the boom here, and so some of that has obviously leveled off a little bit. But that straight line probably is not correct, and so I would definitely take that straight line with a grain of salt. We've seen it not necessarily be true in Ontario. But we said, let's take that as a given, let's take that as worst case scenario. If we are looking at doubling the demand in Alberta, what could we be doing to fill that gap with clean energy? Is it possible to double the electricity demand in Alberta without doubling the emissions, basically? And so that was the challenge we looked at. I won't go through all the different technologies, and you can read, they're all in the report there, but you can read about that in terms of what we were looking at over the next 20 years. And so the scenarios that we handed ourselves was said, okay, let's assume that the demand's going to double in 20 years. Let's assume that we don't want to build any new coal plants. We don't want to build any new nuclear plants. We're going to use only technology that's off the shelf today. So 2008 technology, we're going to assume there's no improvements in solar, there's no improvements in wind, there's no new technologies that get developed. We're going to look at rates of deployment of renewable technology that have only been done in other jurisdictions. So Alberta is not going to do better than Germany did on a per capita basis. It's not going to do better than Denmark. It's not going to be a leader in any way, shape, or form. It's only going to do as good as other jurisdictions have already proven is possible. We didn't want to double or triple the cost of electricity, and so we're looking at what could we be doing under realistic cost assumptions. And obviously, you have to be able to meet the peak as well as the overall consumption. And so those are I think, are a fairly conservative set of assumptions that we used. And then we said, okay, given where the demand is going, what types of technologies could we be using to meet the demand of Alberta over the next 20 years? And what we found is that you could actually meet the Alberta demand. I know it's hard to read, but you can meet the demand for Alberta over the next 20 years without adding any new coal to the system. Using largely by ramping up energy efficiency, by using a lot more wind power, which is here, and then using a significant amount of natural gas cogeneration. And so I won't go into the details of that, but I think what's important to recognize is that it actually is possible to double the demand in Alberta without adding any new coal plants or without adding nuclear power to the grid. Now, that was an interesting conclusion that we came to, but I think what we quickly realized when we were looking at these numbers is that we actually didn't solve the problem of the base load of coal. We didn't get rid of what is already the dirtiest system in Alberta. And so we said, well, what could we be doing any better? Could we let's assume that there was some real political will to really deploy some of these technologies. Let's assume that the technology improves maybe a little bit over the next 20 years, that solar might get a little more cost effective over the next 20 years. Geothermal technology might improve or might be available. Wind power is going to get a little more cost effective. We're going to have a little more transmission. So basically just upping the assumptions by about 10 to 15%. If we made those assumptions, we found out that you could actually deploy all sorts of renewable resources across the province, including hydro, including solar, to the point that you would actually have a whole bunch of excess power on the system. And the way we did this analysis is we analyzed each different technology individually. We said, how quickly could we deploy that technology? What are the grid constraints? And we vetted this information with the Alberta Electric System Operator, with some utilities, and with the different energy societies across the province. And so we looked at each one of those wedges individually. We weren't trying to get to an endpoint necessarily, but how quickly, if we really wanted to, how quickly could you deploy each one of those technologies? And so I think that's probably realistically, not theoretically, but realistically, how quickly you could deploy each one of those technologies over the next 20 years, given what we know about them right now. And what it turns out is that surplus supply, actually, if you take that exact same graph and start phasing out coal today, you could actually phase out coal in Alberta over the next 20 years and double the demand and meet it with a much cleaner system. And so Alberta has the potential, there's enough renewable resources in Alberta to realistically start phasing out coal today. And so I realized I went through that really quickly, and there's all sorts of technical assumptions that are in there, but I wanted to just throw that out there in terms of what we need to be thinking about in terms of what's possible in Alberta.